look into the future about what we can expect. No, please stay here, if you would. And the other members of the panel, plus Dr. Bork, if you'll come along as well.
We're left.
Oh, attrition is beginning to set in. Are there some questions? And perhaps if we could have the microphone down to the center aisle.
I apologize for not being very nano, though. I was macro, as you can tell by the weight of my patients.
Jim Leary at Purdue. It's interesting with the two survivors of this session are very closely linked, and I was many of us are actually trying to develop. It doesn't have to be nano. Many of us are trying to make micro-sized portable devices for not only doctors' offices but for literally to carry on the person. In fact, my group has been trying to develop basically a blood analyzer which would work great through a phone, which is the proper format for it, that would literally analyze everything. You wouldn't go. There's no reason to go and collect blood at a have a phlebotomist do that. You can do that with nano and micro technology that is virtually painless. You hardly, it takes a drop of blood. You can analyze. Other groups have done, maybe 200 different analytes, and that can be all done by telecommunications. So to me, it's the trends that you have said that Motorola's interested in. That's an obvious solution. And what we've seen, it's amazed me that we hope to get any kind of useful information on the random event in a doctor's office. And the only right way to do it is to actually monitor. Insurance companies are starting to realize that, and to pay for the monitoring, to take a device home, and simple things like blood pressure, obvious things, but these things would pay for themselves many times over. So to me, I'm astounded that the insurance companies haven't jumped all over this to drive it that way. Just all it takes is one bad incident to pay for an awful lot of ones which you could make a lot of that pretty cheap, and you could make decision algorithms. It wouldn't take a lot of physicians' time to do this, so I can't imagine why it would be very expensive to really implement, if you look at the overall cost savings, bottom lines.
One thing I didn't mention is that with the Chronicle device, it's now linked in the same can as an ICD, implanted cardioverted defibrillator. I call it the Chronicle lifeboat. It's there to not only detect, but also the shock. And we're in the middle of a large study. Medtronic funded a 1,500 patient study for that because they like ICDs. And I got Blue Cross in Alabama to actually pay for those implants because they were getting the ICD anyway. I showed them the data from the Compass HF that we can also improve heart failure, and they're actually paying for that, as is Medicare. They're paying for those implants.
Relagela Spanky, Hong Kong U and MIT. Couple of questions. I'll start with you, Robert. Has there been any restenosis or issues with that MEMS device sitting there because it's sort of stuck in the center? Are you seeing any damage to the vascular walls as a result of that sitting there, or increased turnover of red blood cells or anything like that caused by the change in turbulence and flow in that area?
No, the device, the CardioMEMS device, specifically the tiny one, is available to be used as an aortic endograph monitor. So it's been around for a long time, more than 8 years. And it's no battery and has an indefinite life. It says no battery, it's charged from the external. In the animal studies, nothing. We did a series of studies with two of my former fellows in South America where we tracked them, patients. We tracked 60 of them for a total of 18 months each. Nothing. We did serial perfusion scans. Some patients we did CT scans. Nothing. And the patients that have died, which are very few, we were able to get pathological specimens. It's sitting there in the middle. It's endothelialized and continues to work. So far, and 220 implants, none in humans, and none in the animals either.
And have they looked at putting one on the outside of either the artery or the vein to go ahead and look at
They
change in
have,
stretch?
I guess I can comment. Interesting enough, if you put this CardioMEMS monitor at the time of surgery on the pulmonary artery in the fold of the pericardium, you get identical pressure tracings as if it's inside. Exactly right. And I'm on the committee, we're devising a surgical study for post-surgical monitoring in patients who are already going to surgery. You just slip it up there and it works fine, forever.
Very nice. Have you looked at using, we saw a very intriguing picture of using cell phones. Have you looked at some of the latest data that's been coming out on using a microphone in the ear to go ahead and detect the complete heartbeat and the change in heartbeat over time?
I have.
What do you think of it?
The problem is there's too many external variables, I think. For example, especially in an emergency, an emergency situation, somebody falling down, hitting their head, and the external things that occur with emergencies, I don't believe that's going to work quite as well down the line. Now, as the algorithms get better to exclude some of that extraneous information, maybe so, but then I worry we're going to miss something. I always like a lot of data. In fact, one of the problems with me presenting to the FDA is I keep saying, not everybody's going to look at 5 million pages, Bob. We need to make it easier. In fact, the newest version, which comes online in 5 weeks for the Chronicle device, has an auto-detect algorithm, which is remarkably robust. So I won't get the page unless it goes not just out of line, but a trend set that I have out of line, individualized.
And have they looked at coupling that with a delivery device to go ahead and actually do the intervention after it recognizes the aberrant pattern?
We've been talking to them about that, including with Martine, for 4 years now. And the hurdles to that, because of limited market. See, for Medtronic, this is small.
Right, yeah.
It's
Yeah.
a blip on their radar. Everything we do, having worked with Medtronic 15 years, and I love the company, but if they can't make 80% profit within 2 years of introducing something, they're not going to do it.
Thank you.
Another question, please.
Okay. I'm Jaideep Maburi from NeuroVista in Seattle. Great talks. I had a quick question for Dr. Burge. Since you're clued in on the VC activity and such in the cardio world, what do you sense are the next immediate technologies? So we have electrical sensing and we have pressure sensing, but what are the other things that are going to be implanted into the heart?
We're going to have electrolyte sensing, probably through the skin, through some nano sensors that are being developed in Ireland, I believe. They have technology which places not only a delivery system for insulin, but a detection system for electrolytes and maybe renal function. I would like to have remote BU creatinine, because one of the things that limits my diuresis, and I still have to have patients go to their local doctor and check a BU creatinine, because I want to make sure that I'm not lowering their filling pressures too much and affecting their renal function. There's a whole lot of things that we're looking at. The closed-loop system we've been using at UAB that you described since 1981. John Kirkland developed his own closed-loop system in our cardiovascular ICU because the patient post-operative can't move. So everything is weighed as they come on the patient. Blood loss is automatically recirculated through cell savers, infused back into the patient based on left atrial pressure measurements. It never got outside of UAB because he was concerned about UAB. So he never tried to get it FDA approved, but we're still using it now. To this day, everything's automatically recirculated in. But to get to the next step, to have the feedback, getting that past the FDA, as you can imagine, is quite difficult. The heart saver pod, the heart pod that I told you that crosses the left atrium, it is a direct feedback system. The patient carries a PDA, it's actually a palm device. It has no batteries, no storage. And what the patient does, now once a day, maybe twice a day in the future, is he holds up the palm, it reads the information. then it tells the patient how much Lasix to take based on that determination. And it's an individually prescribed dose of Lasix. I believe that is the way to go, quite frankly, because it's so much for me to have to look at. The problem is you still have to look at it. If the clinician's not looking at it, the patient will almost always over-diurese themselves in time. They'll cough, they'll have an aberration in that one single reading, and they'll continue to push their diuretic because the machine's telling them to. So I've insisted, and they've written in some algorithms, so if you've had to take a higher dose 2 days in a row, call your doctor, such as that.
What's the power source in that case?
The power source comes from the device, which is powered by 2 AA batteries, and it lasts about 3 months.
Another question, please.
Yes, Selmer Bringstra at RPI. Thank you very much for a couple of very interesting talks. The trends that were being described there, I accept as ones unfolding before our eyes, with the exception of intelligence. I think you'd have to show me what the empirical evidence is for that. In the 70s, AI was of the opinion that the kind of diagnoses that Dr. Bourget has routinely engaged in to save lives would be done by a machine anytime. So I don't see that at all. And to the extent that I will, not generalize at this point, but to the extent that nanotechnology requires intelligence be on board the particles, devices, robots, or whatever you choose to talk about, there would then be reason to be concerned. So I'm just wondering if you might have a comment or two on that.
There's a trade-off between, the question is, why do you need intelligence? You need intelligence if you want decision-making at any given instant or any given spot. The alternative is you let somebody else who you trust to make the decision for you or provide the guidance. The difference between the two is the amount of information that has to be sent somewhere, and the analysis has to be done, and you lose time. So you're right in the sense that today you may not necessarily see the intelligence at the level of AI in the sense of fully programmed, independent, autonomous systems. You don't think you're going to see that. But what you're going to see is a gradual migration at the point of use of less and less data being required to be interfered with, transferred, and the question, I don't know the timeline on it at this point. But you're right. I mean, it's not, today if you ask me, do we have a system that is fully autonomous, it depends on the use. A lot of the stuff that the consumers might be interested in. For example, I didn't mention it explicitly, but a lot of the stuff we are looking at is not necessarily information out of your body, but it's actually information that affects you based on the environment you are in. So everything you can possibly imagine from the air you are sitting in, to the car you might be driving next to, the traffic conditions that you're sitting in, to the water you might be drinking in. That type of stuff, you can actually narrow it down and provide just basic screened summaries that you and I as a consumer might find valuable, but it's not necessarily intelligence in that sense.
Yeah, no, thanks. I certainly agree. I would say that in your diagram regarding sort of bringing action closer to yourself, your car, your home, it is interesting that education appears to resist that trend.
That's correct.
Distance education, to some degree, of course, still goes on, but people are willing to plunk down $50K a year to send their kids off to Harvard and say goodbye to them for a while. The major reason for that, I take it, is that communication. So I agree with you about bringing data in some quasi-intelligent way to the human decision maker, that's accelerating and so forth. But we have a communication problem that we can't seem to crack. The systems that we got very excited about in the 50s are today about as articulate as the most articulate systems we have. And so to break that barrier that you're talking about, we'd have to get to the point where the machine could could presumably communicate with us.
Were you questioning the expert systems, the ones that were developed in the 50s at University of Pittsburgh and elsewhere? Was that what you were directing the
Yeah,
question to?
I'm a fan of those. I wasn't questioning them. I'm just reporting first historically they existed, A, and B, they were venerated by pretty much anyone who was sort of a computationally inclined intellectual at the time. I mean, there were very few naysayers. Most people said the problem was political, that doctors would resist, but they would not resist for technological reasons. But that has not happened. The crackerjack diagnosticians of today, and I think we've seen I think we've seen one in action, at least recounting his saving the day a number of times. That really is a level of, to use the relevant verb here, decision making that a machine cannot, as a matter of technological fact, muster today. So I was just reporting that.
Could we make the question fairly quick, if you could, please?
Well, it's following up on the last one, because I think it's a good fraction of this conference concerns decision making. And I would submit to you that I think the problem with artificial intelligence is that the standards that people tried to set out the standards were too high. And trying to make something completely autonomous and to solve 100% of the problem is extremely expensive and extremely difficult. But if you look, as you just illustrated right now, you can have an algorithm, a simple algorithm, that could take care of 90% of the cases. So we say a problem is defined in 3 parts. The first third of the problem is the first 90%. The next third of the problem is the next 9%, and the last third of the problem, in terms of effort and cost, is the last 1%. So if we look at this intelligently and say, first of all, it just has to be good enough to get us partway there. And the second thing is that I think the other compulsion that artificial intelligence community got into was understanding why. And when they tried to interview experts to figure out how they did what they do, the experts couldn't tell them, because experts do things without knowing. I'm an expert in one particular thing, and I can't tell you how I do it, but I do it very well.
We call it a gut feeling.
That's right, but it's very subtle, and you can't come up with a set of rules. And so there are a lot of black box solutions, including things like neural networks, that offend people because they come up with solutions, but we have no idea how they do it. They just do it by natural sort of selection of the selection of the winners. But if we get a little less compulsive about how we reach a conclusion and just look at the utility of that and say, why don't we just come up with ways of coming up with algorithms and solutions that are cost effective and go the part of the problem. We don't want to take the decision making away from the doctor. What we do want to do is have you not have to spend time reading 5 million pages worth of data. That's a poor use of your time. On the other hand, if that were distilled in a way that you could look and use your judgment factor, that's how we should be using your time. And then you're also going to get acceptance from doctors, because that's how it's not that they're resistant to technology, it's that they know that there's an awful lot of things, as we said, artificial intelligence is still not at the level of a 2-year-old 50 years later, because it turns out what a 2-year-old does is very difficult to program.
Well, I'll just make a quick comment, and there are 2 practical thoughts that go with it, and they're purely, one is a technical issue and the other is an economic one. One is the amount of information you can physically collect on the smallest chip or a portable electronic piece is huge. The reason why you might not want to is a trade-off between power. Shipping something, transmitting data somewhere else versus solving the problem at the point of use. And if you can come up with clever algorithms and have to make decision, it helps the device power. The second part is, if you're looking at it from an economic standpoint, companies are eventually out there to make money. You make more money selling a system that eventually has to look more complicated than it is to provide a piece of thing that says, I've done all your answers for you. Well, then we all go out of business. So,
if I may conclude, I just wanted a couple of comments. One, an interesting use of these kind of devices is the ability to survey species. There's a technique of developing barcodes for insects. It's been used on other animals, where you can take a small piece like the leg of a grasshopper and sequence that. There's about 600 base pairs. And according to the people using this technique, that provides a very clear distinction between species. And so the issue now is to have a handheld sequencer.
Right.
And just to mention the fact that it's not widely known that the whole MEMS applications started at NASA. That would have been about the time of the planetary programs when they were going to Mars. And they wanted a measurement of a rat's heart valve. And the device was placed on it, which was one of the first MEMS devices. And the other was a gas chromatograph that went to Mars. And that required MEMS devices. And now so much of what's happening is dependent on it. Now, what time should we return from our... So 15 minutes and...